it's Gadget UK here again. I'm having a go at the 16 MHz mod for the ST again. This is about the third or fourth time I've attempted this, using various sort of changes to the circuitry here. This latest version has come from Exos. He's designed this and run it through a simulator, so there's a few things on here that as he's pointed out, that you don't use in the real world. You don't need these 04 chips. And incidentally, I think he's used F74F chips, which are presumably a fast TTL for all of these. So 74F32, not HC32, 74F00, 74F08, 74F02. So it looks pretty straightforward. I know now I can take my 16 MHz clock from pin 39 of the video shifter. 8 meg I'll just take from straight underneath the board where the clock pin is. I forget which pin it is, it's like 12 or 13 or something, I can't remember. Looks pretty straightforward, yeah, so you've got four of these chips, as you can see. I've got multiple of these just in case I need spares at some point. I want to do another one of these mods, but yeah, I've got 3 there to still stick on, 1 stick on there. I've cut this piece of this Veristrip board down to size. It went a bit skew from one side. I filed it down so it is totally even, but there's a bit of copper, as you can see, still left on that very edge there. But the way to do this is to give yourself enough space. So I've done it so there's like 3. The next chip will go on where my thumb is there, covering that row of pins up. So you'll have 3 rows there in between, which allows you to separate them from each other. It's sort of important you stick them this way on the thing, otherwise obviously all your pins will be joined, and it's very messy. In fact, you can't really do it the other way. If your chip goes around the other way on the Veristrip, it just won't work. You'd have to use a Stanley knife or something to cut it all. So this is the way around to do it, so that the lines go down the board in parallel with the chips, and then obviously you've got to separate the centres of those, and like I say, separate each chip from each chip. So that's why that's why I've been cutting these holes like this. Incidentally, you can do it with a screwdriver or something like that, or even a drill bit, but you can get a dedicated track cutter for these Veristrip boards, and that's what I'm using on this. So as soon as I finish that last row there, I'll get the other 3 chips on there. And what I'm going to do is I've left a trace, if you can see, at the edge here on both sides. And what I'm going to use, one side is going to be the +5, one side is going to be the ground. And then it's just a case of, because if you look at the pin outs of these chips, you can see like pin 14 is VCC and pin 7 is ground. So it's quite convenient to just bridge from the pin straight to the track there on both both corners, and you can do that for each chip, so you can tap off the +5 and ground relatively easily there. And then it's just a case of just putting some jumper wires. I realise that's right to the edge there. You've not got much room to solder any wires. You have to solder directly onto the edges. But the beauty of this is not all the gates are used. There's only a couple of gates on each chip, and each one of these chips will hold 4 gates. So I can put the inputs into the bottom part of this chip here, in some of those, the row of pins that will be spare next to where it's been soldered. As you can see, they've got 1 row. When the thumb is there, you've got 1 row of pins. So I can use that of the inputs and outputs of the first gate, do the same all the way down through these. So there'll be some wires, going across to each chip and stuff, joining them up. But it should be straightforward with the first few. I think the last 2 is going to be a bit messy, because if you look at the diagram here, you've got it's dead straightforward, as you say. Right at the start of the diagram, you've got your 32, 74F32, 74F00, and then this is where it gets a bit messy, because you've got the inputs from that 00 going to your 08. But they also go into this 02 as so there's no easy way to identify, no easy way to put one round the, I don't know what's the word I'm looking for. There's no easy way to accommodate that. Really, you're going to have you're going to have some jumper wires going over the chips, no matter which way around you do that. If you put the 08 on first, then you're going to have to jump over to the 02 and vice versa. So, but yeah, so the way I'm going to do that is stick the 7432. F32 on there first, then stick the 74F00, and then probably the 08 and then the 02, and just do all my jumper wires. And a good way of doing this, one of these, if you don't know, if you've never done one of these before, and it's important, I'm sidetracking here, but when you look at the diagram like this, obviously there's no pins, there's no pin outs, it's just showing you, you've got a gate there, an OR gate, So you've got to be able to translate that into the chip itself and understand what the pinout is. So if you look at, say, the text sheet, the data sheets for these text spec, quad input OR gate, and I've covered one of these before, and this is not a great diagram because I prefer the ones like these ones in this Fairchild where it shows you the pins and shows the actual gates within there, and that's really easy to translate. But in this case here, you've got this little logic diagram here where it shows you you've got this D0A, D0B as inputs into the little gate there, and they are numbered 1, 2, 3, Q0, and then you can use those the references there, looking at this diagram here to work it out. So and the pin numbers I think are the same anyway, so it's pretty straightforward. And that's what you've got to do really. You've got to say, okay, what's an OR gate? You've got 2 inputs, and work out what pin numbers you're going to use on your chip. Some people like to plot these out on a piece of graph paper or something first, before they start laying the chips out and stuff and doing the track design. And there's probably software out there that can help you do this as well, but I'm not that familiar. I'd be interested to know what Exos has actually done this in. I forget now. There was I'll put a link to it in this video, but there was some software that Dave Jones pointed out that looks pretty good for doing circuit simulation and stuff, and it may well be the same software. I don't know, but yeah, I'd like to get my hands on a copy of this to have a play around with this, because it seems like it's mega useful. Anyway, I'll get back to this now and I'll show you what I've done. So as you can see, I've got 4 chips on there now, and I've got a break, like I've broken the tracks in between each side of each chip and each chip all the way down there. This is a good point really to get your multimeter out, put it on continuity. Just test at each pin to make sure you've got no shorts between each pin, both sides on each chip, and then also check from each chip to each chip just to make sure you've got them isolated properly. I think what I'm probably going to do with this is use some K&R wire, or K&R wire, call it what you want, to do the joins, because previously when I had the prototype on the other board for this, I did using the original schematics, I had some pretty thick wire and it was just unwieldy. It was really hard to manage, and it just makes a mess, especially on the soldering underneath as well. Using something as fine as that will make it much easier. So I'll have a go now at starting doing the wiring, I think. Before I do that wiring, actually, I'm going to join up the VCC and ground, +5 and ground, as I say. So pin 14, which is that top left pin there, is your +5. So each one of these top corner points there, pin 14 on each of those chips, I'm going to join to that rail there just by bridging. I'll just bridge the solder across from that pin to there, and then from that pin to there, all the way along, and then do the same thing with the ground, the opposite sort of diagonal end to the other rail on the other side. I connect a couple of wires up, so I've got my +5 and ground, and that'll just remind me that I've dealt with that and I don't need to worry about power and ground to either of any of those chips. Okay, you can see now where I've joined up the +5 and ground. I've got, like I say, the top pin there, pin 14, top left, right next to my nail. If you look underneath, it's, like I say, it's shorter to this rail here, and it goes all the way down. Same thing on the next chip, pin 14 on the next chip, pin 14 on the next chip. So all of those are all joined to that single rail. And then what I've done is the red wire from where my +5 is going to come in. If you see where that joins, it joins to one of the pins, the pins that already connect to that rail. So that whole rail basically now should have +5 down it. And it's the same thing with the ground. So like I say, it's diagonally opposite, and I've done the same thing with the black wire. I've just found the nearest place where I can join it to one of the pins that's already connected to the ground rail that goes down that side of the board. So that's me +5 and ground, VCC and ground sorted out. I just need to do some joins now, basically, between the different gates, according to this diagram that Chris Exxon did me. Hopefully there's not going to be too much more to do. One thing I will have to do is on this diagram, this shows here, not to be using real well, these are usually, you've got to separate these, BG and AS. You can't short them because it'll screw up other things. They are separate on the chip itself, on the 68000 processor. So I'll have to have a wire coming in from BG, a wire coming in from AS, and I'm guessing this is the switch, and it says override forced when it's high, 16 MHz, low normal switching. So I'm guessing that's the switch. He did mention something about the ROM, the override being something to do with the ROM modification he's looking at, so I'm not really sure. I might have to switch this another way yet. but we'll see what happens. As you progress with this, one of the things that can sometimes help, as you can see, I've done two of the tracks there, and what I've done is I've joined pin 3, which is the first output of my 32 gate, into pin 1, which is of the 000 chip. So it's like, you know, an output into an input, that's correct. And then I've taken pin 6, which is an output from the second OR gate, into pin 2, which is, you know, that's right, you've got pin 1 and pin 2 as inputs into the 00. So that's what those little pieces of KNR wire are underneath there. But if you use a highlighter pen and highlight over the traces you've done, it makes it really easy moving forward. You know, you can see this, you know, other than the input stuff here from the AS, B, G, and the switch circuit, I'm probably going to have to add on there to be able to switch it on and off. There's not a massive amount more to do here now. I'm just going to take the output from the 00, stick it to one of the gates of the 08, and into at the same time into one of the gates of the 02. Interesting, both of the gates are joined on this 02, so this is no more than a buffer. I guess that's a NAND, so it's going to be an inverting buffer. It looks like a NOR gate actually, because if that's an OR gate, yeah, that's a NOR gate. So it's just going to be an inverter that effectively, because both gates are joined together. So that's really easy to do. You know, underneath you can just solder the two pins together, and just a single trace there from the output of that into there, and then the same thing, you know, into the 08. You know, there's just a few joins then between these chips, and obviously originating clock signals. That's what these represent here, coming in the 16 MHz clock and the 8 MHz clock. So yeah, I'm going to have a couple of wires, a wire for the 8 MHz and a wire for the 16 MHz. Pretty straightforward really, so yeah, I'll crack on and hopefully get it finished shortly. Just a quick update here. I'm hoping for some advice really from Exxon. I'll show you what's happening with this. It's a state again, you know, it starts off really tidy and neat and all the rest of it, and ends up with caps strewn across the board and jumper wires and everything. But I've done a lot of diagnostics on this, you know, stepping through and checking with the logic probe and the oscilloscope. I'll show you what's going on if I just think now, just switch it on it as it is. I'll show you screen. So I just get a white screen, press the space bar, nothing. Now normally you get a key click, and in fact if the keyboard's disconnected you'd hear a repeating key click. So that's the first thing, and what I'll do is I'll just show you on the scope here what I'm seeing. Right, I'm just about to power it back up again. First of all I'm going to probe the output of the board. So this is the clock that comes out of this little mod that Exxon designed. That's interesting. Yeah, so 16 MHz, it's already on, so I'll switch it off. Switch it on. You can see now it's gone to 8. It's not a very clean signal, but that's exactly what I'm getting coming off the board. But as you can see, that's not switched, but you can see a little bit of ghosting in the background there. I'm not happy about that to start with. I can pre-press the reset button. You can see 16 to 8. 16, reset it again, it's stuck on 16. Reset, 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 hold reset, reset. So it glitched there, and there you go, back to 8. Look at that, that's a strange signal. 8 again. This is me continuously pressing the reset. 8. But most parts seems to be stuck on 16. Now what is interesting, I'll switch it off again, and I'll show you the signals first. I'll switch it back on. What I'm going to do now is put the pin, the probe, into where the 8 MHz comes into the CPU on the board normally, and for a space, so I'll have to reset it while I'm holding the probe there. Now the impedance of the scope, yeah, that's working. Now if I just move the camera over, this is going to be a bit hard. You can see this. I'm probing the pin. I've bent the pin out. In fact, it's snapped off. Long story. But anyway, the pin where the clock normally goes in, that's where it is. And as you can see on the screen, you get the psychedelic colour show going on here with the shifter chip. But the interesting thing is, like I say, if you look where I'm probing, so it's going to be hard this because I'm only got one hand. I'm just probing that pin. It's something to do with the impedance of the scope being connected there. As you can hear, it's you know, I can press the space bar, it works. You just get this you know, weird psychedelic stuff going on with the display. Now if I do the similar thing, if I take that off, in fact, you'll find, there you go, it just freezes. Dead, died. I'm guessing I've got a CPU halt or something going on there. If I do the similar thing on the 16 MHz clock pin, and I'm taking this from pin 39 here, I've probed all the other pins, I can't see anything else that looks remotely 16 MHz-ish. But if I show you on the scope, again, sorry, can you see that's looking like 16 megahertz? You can compare, if you look at the gap there, the time space or whatever, and I compare to where I'm getting the 8 megahertz from. You can see that's the 8 megahertz. The amplitude's a bit higher than the 8 megahertz, definitely. It's not a very clean, it's not a sine wave, I don't know, something else is generating that, I guess, somewhere on the board. But back to the 16 megahertz. Sorry, you probably can't see this. I'll show you the 16 megahertz coming out of the shifter chip. I might need to zoom in on that, but you can see that. So we've got 16 megahertz on the shifter chip there. And the interesting thing is I'll show you what happens on the screen while I'm probing that. Again, due to impedance. Sorry, I'm zooming in. I'll reset it. See that? That's just from the impedance of the scope there, on ×1. Again, you just can't do anything, take it off, and occasionally you'll get a desktop like that. Can't do anything, it's halted. So, I don't know, I'm absolutely lost with this. Like I say, I've done quite a bit here. Yeah, I mean, the wire, the 16 megahertz wire there is pretty long, it's pretty thin. Is it that? Is it length? You know, I was looking at the shots you've got of your breadboard there, and again I've got 8 megahertz coming from the board there. I've checked that, that's a suitable replacement that goes to the input here. It's definitely short. So, and there's nothing wrong with the pinouts and stuff. Definitely used the right chips. I've used all 74F chips. Just curious, really. I can't understand how, you know, just the impedance of the scope being on that pin. Let's say I reset it. No, it's working, but it's working with an issue with the shifter, as you'll see. It's like, what's that all about? I'm not really sure what's going on there. Be interested, if it works at that stage, I'd be interested to see if you could get a benchmark up to see whether it's actually running at 16 megahertz. I guess it is. It's hard to tell really. As soon as I take the probe off, obviously it'll go, but not sure if there's another underlying fault here with this ST. I mean, now the ST works, so I wouldn't really say there's a definite fault, but I mean in terms of, I don't know, the electrolytics somewhere around on the shifter circuitry and perhaps need replacing or something. I don't know. Would that cause this sort of problem? I doubt it. It seems strange that the impedance on the 8 megahertz clock would cause this to work, which suggests something wrong with the I don't know, I'm at a loss to explain it really. Don't understand how I could be having this problem. Unless it's the length of the wire. I'll try and shorten the 8 megahertz wire and see if that makes any difference.